About a year and a half ago, I was asked to work on this project with a few friends of mine that play music and play in a band, and they wanted to take their audio samples on tour with them. And these guys are not tech guys. They are not programmers. They're not people that want to take a laptop on stage. They just wanted it to be really straightforward and really simple. And so through the process, I was trying to help them out. I found out about JUCE and started researching it, got really interested in it. Got Martin's book, tried to learn as much as I could on it. And then I couldn't really find anyone else around town that was using JUCE, or it wasn't really prevalent to me. So then I went ahead and made the project, and the band took it on tour, and it never broke, so that's my claim to fame. And then I heard about this conference, and they were asking for people to talk about it, and I was like, this is my perfect chance to finally talk to someone else that knows about JUCE. So I'm really happy to be here, very excited, all you JUCE people in the room, and thank you all so much for having me today. And so I'm just going to get into it. Squeezing JUCE out of your laptop and into the real world. Kind of a corny title, it's about taking it away from this form and taking it into like, maybe like this form. So basically, my talk is going to kind of focus on assuming you're all programmers and assuming that you all know about plugin development, and you're honestly probably all better JUCE software programmers than I am. But just thinking back to the user point of view a little bit more. And so you look at these devices on the screen, and like right here, this is a guitar effect pedal board, right? So we're probably familiar with these. Got like overdrive pedal, wah pedal, fuzz pedal. And these are just devices with like a few knobs and an input and output. And that's what the users understand. There's a whole world of users that they just get that. They don't really want to like pop open like a software application or anything like that. These are Eurorack synthesizer modules, very fun to play with as well. And this is like a teenage engineering device, which is also a really fun little beat calculator kind of thing. But these are just single purpose devices, And so I'm going to introduce my project real quick. So this is what I made for the band. And I have a little video demo I'm going to play. And uh-oh, you weren't supposed to see that yet. Hold on, let's go over here. Here we go. And so a disclaimer, this video does show some bare feet. And it is, it's not showing. Let's see here. What am I doing wrong? And there is a misspelled word somewhere. So just to let you know. There we go. There we go. Can I do that? Okay, here you go. Oh dear. Sorry, I should have planned this out a little bit better. Here we go.
Make it full screen?
Yeah. Okay, so there's no sound yet, but this is it just turning on. This is the device in here. So there's a little embedded computer in this silver box right here. And yeah, you shouldn't hear anything quite yet. Oh, there's the barefoot. Watch out. And this is a MIDI controller that's just plugged into the device with a USB chip, or a USB cord. So what's in here is basically an embedded Linux device, like a BeagleBone, maybe some of y'all heard of that, or like a Raspberry Pi. And that was it booting up. Then the green light turns on. So that's basically, that's to show that's how simple it is. Like, it's just another thing that goes on top of the guitar effect pedal of the guitarist, and he just turns the knob on, and that's all he does. And the way they used it is like how you're hearing, which is basically the guitarist would play guitar, and then he would control the sounds with his feet. And because they wanted to have a few organ pads along with their sound, but they didn't want to take an organ player along with them. So, I was the organ player at a certain time, so I guess I just programmed myself out of the job. But these organ samples, that's a whole other like world that I'm not actually really going to talk about today. But those are real 1960s Farfisa instrument samples, and so they're not synthesis. And it was a really complicated process to actually get the samples out with the vibrato on, all phase aligned. So that way, I had to basically feed in a fake low frequency oscillator to the circuit when I recorded it, so that all of the pitch modulation effects were in line with each other. So that way they could be played back, and the vibratos wouldn't be like shifting up and down, one going up while one's going down, and it sounded terrible. So anyways, that's it for all my YouTube. You can check that out later. So let's see here, split screen. So that's the device. And here we go, we'll jump back into presentation mode real quick. And doing good on time. Okay, so yeah. So play auto samples, MIDI controlled, easy, reliable. Y'all get it now. Okay, so my idea here is to show you what it takes for you software engineers to get your devices on these embedded Linux prototypes as well. So what does embedded mean? Is there anyone in the audience that has like a lot of experience on hardware or anything like that? Excellent. So whenever I get the question that I don't know how to answer, I'm going to ask you. Thank you very much. So basically, embedded Linux development. This is ARM-based chips, not x86. So ARM is kind of like what's running on your cell phone. It's like a system on a chip. And that's what my job at Samsung is. I help make these chips that run in Samsung phones, or also some Apple devices, but don't tell anyone that. And just different things like that. Basically, these things are going to generally give you less memory, less processing power, so you have to be able to deal with that. And what I'm specifically talking about is not real embedded, because it's not actually bare metal systems. These are systems that actually do have operating systems on them. And they have, I'm using mostly Linux operating system to run on these devices. And these are two major players in this world. If you wanted to just go down the street or go online on Amazon and buy one, the Raspberry Pi and the BeagleBone is what I used. But I actually have found the Raspberry Pi to be more user-friendly. So. First thing to talk about is, as we're JUCE and we're audio developers, how do you get audio out of these devices? So that's the first hurdle, is because specifically on the BeagleBone, there is no audio output on that little chip. And so you have to figure out some way to have some sort of audio module, audio card to connect it to. So I just kind of laid out these three methods that you can use, and you can really use any of them. And basically, they all run underneath the Linux audio drivers, ALSA and Jack Audio. So what I found was, whenever I was using JUCE to work with these devices, it was relatively simple. And there's a lot of underlying software stuff that I'm really not that I don't really know that much about, so I'm not the best person to ask. But first option is onboard audio. That's on the Raspberry Pi. And the onboard audio is not really the best. That uses a pulse width modulation technique to create the audio, which is basically the same thing that a lot of like power inverters use to create that 50 hertz power cycle. That you use for like AC power. And so that's good, but that's good for like low frequencies. But we want like high fidelity, high frequency, 20K, So that's good, but not super high definition. Next option is just a USB sound card. You can buy like a USB dongle to plug in your headphones or plug in some sort of speaker device to. That's better. Sometimes they can be buggy, like if you buy one on Amazon from some like random distributor from China, sometimes you'll think you have a software error when the whole time it's just a hardware malfunction. So those are cheaper, but I don't really recommend them. The best option that you have is to get a proper DAC, digital to analog converter. And basically, this uses a digital protocol known as I2S, which is nothing really different from any sort of real serial communication protocol. There's like books on this stuff, so I'm not really going to go too in depth with it, but basically you can just Google Beagle or Raspberry Pi I2S DAC, and there are manufacturers that make these shields or these like little boards that are just kind of plug and play. They just pop right on top of the Raspberry Pi, and you don't really have to worry about what's going on electronically in there. And that'll give you a really high quality audio signal that could be up to whatever the chip or whatever your hardware limitation is. So 192 kilohertz, 32-bit, maybe. I haven't actually tried that, but there shouldn't be a reason why you can't do that. Let's see, next. So this is what's inside my device. And so I did probably the worst decision out of those three options is I decided I'm going to make my own deck. I thought it'd be fun to like make a PCB. I went and studied electrical engineering, and I never really got a chance to like make a useful PCB. So I went and did some research online. These are two different versions of them. Basically, you're seeing here, so this is that beagle bone underneath inside the box in the red or in the orange square. And then right here, you see this PCB that I made, and basically that's based on some Texas Instruments chip. And they kind of give you, if you go in the data sheets, they kind of give you all the answers you need to know. They show you the demo schematic and stuff. It's a great learning process. And so then you can go through and you just hook up. This looks really messy, but basically these are like the 4 serial communication wires. Now, if you get one of those chips that like I told you should get, where you just Google Raspberry Pi I2S DAC, you don't have to worry about hooking up these cables because they're just made in the form factor where they'll just plug and play. So that's probably a better option. And then over here, this is just a volume knob. It's just all analog. That's the audio signal coming out into a voltage divider. And this is just a USB extension cable. So this is straight to the USB port on the device. And this is so you can plug in your whatever MIDI controller you want, or whenever you're developing, you're going to have to probably plug in some sort of USB device sometimes, like a keyboard or a mouse, just to kind of get the device up and running. This was the cleaner form factor, the second edition that they actually took on tour that was sturdy. So that was the kind of hardware need-to-know knowledge. Now it's just the software side. So these devices are just computers. That's all they are. They're just small, little, simple computers. So you can plug in, this is my kitchen table. You can plug in a mouse and a keyboard, and you can plug in an HDMI monitor and turn it on, and it's just a little Linux computer. Usually the operating system is like some sort of lightweight version of Linux. I found the best luck using a version of Arch Linux to run on these machines because it was a little bit faster boot up time. And some of the times the way these operating systems handle floats can be kind of an issue. I used like, I think it was this one on the Beagle bone that comes on that board is Angstrom Linux, I think is what they call it. And they do something like, I think they do, it's soft float mathematics. So it's all the float math is done virtually as opposed to hard floats, where all of the float math is done with like a hardware chip. And the difference is speed. And so whenever I tried to run like a JUCE audio file with the soft floats technology, you'd get a lot of buffering sound and clicky sound. And I kind of attribute it to probably that was the issue. And once I switched over to using a different operating system, things worked a lot better. So just kind of have that in mind, hard floats and soft floats. But the biggest issue here is that you can't really just go ahead and develop on these devices with plugging in a mouse and a keyboard and plugging in a screen and running up the introducer because they're really slow. Okay, and so what's better is to set up a cross-development environment, cross-compilation and debugging. And that's where things get a little bit hairier. And that's probably where, like, was probably the most difficult thing to set up for me. And so what I mean by that is that you go on your computer, and you go into Xcode, for example, and you press compile, and then that compiles for another Mac computer to run. But you need to compile so that it's going to run on this ARM-based device, not an x86-based device. So you need a specific compiler. Okay, that's not too big of a deal to change the compiler. And I ended up using, whenever I was developing this, I used Eclipse IDE. And you can Google ARM-based C++ compiler. I forgot the name right now, but it's pretty straightforward once you install that on your machine. And I think that the intro juicer has some support for that too. They have some like Linux make files that it'll spit out for you. But what's trickier is then the remote debugging, because you want to be able to debug on the actual device and like set up breakpoints and step through functions so that way whenever you see that there's some weird Linux ALSA driver issue, you can get down there to the root of it. So basically the IDE that's best for that right now is Eclipse. But I still found that like not really satisfying. I wasn't really a big fan of Eclipse. And so I was looking and looking and looking before this presentation for how could I find something better? And one option that I think that I just wanted to spitball at you was the Cloud9 IDE. And so that's a web browser-based IDE. And basically that's uses Docker. Has anyone ever heard of Docker in this room? It's supposed to be a pretty hot topic right now. And so what Docker is it's kind of like a virtual machine that you can run on your computer. So you could run like a Linux machine on your computer, but it's a lot more lightweight. And so what's cool about this is that you could set up a Cloud9 development environment that could have all the compiler already configured, all the dependencies already set up. And so that way you can just open up this development environment that's ready to go. And then I was also wanting to do a Docker thing on the actual device itself, because there's also a lot of dependencies to put on the device. And so I did have an example, just in case you wanted to see what Cloud9 looked like. I don't know how it's going to work with this, this display setup, but I'm pretty much finished here. Hold on. Here we go. And so this right here. So basically, this is the Cloud9 development environment. And what I'm working on right now is a new plugin for this IDE that's unfortunately not quite finished yet, but it's making use of this GDB debugger that they have. And as you can see, if I click debug on this program right here, it goes through, and you can see right here, it's already using remote debugging, this GDB remote debugger. And so if you just point that IP address at your local Linux IP address, you could use this whole system as like a cross-platform development environment without having to do all of this other setup that you'd have to do with Eclipse. But anyways, that's basically all I have for you. And so I'm just going to flip back over to presentation world if I can. And thank you so much for listening. And that's my talk. And any questions you have, I will take. Also, the slides are posted on my GitHub right here, if you're interested. Thank you.
Hi, thanks for the talk. What kind of latencies do you get with your I2S sound card on the BeagleBone?
So latencies, that's all going to be dependent upon, I think, whatever drivers that's running on the Linux device. So I didn't have, I mean, you saw the device running on that video, so the latency was good whenever we got to the end of it. I'm trying to remember if I had any big latency problems in the beginning. I don't think I did, but I think you would run into latency problems when you start taking in analog audio. Whenever you start, instead of just taking in MIDI input and outputting analog audio, if you start trying to make like your own effects pedal, like that's one use case that I thought would be really cool for maybe most of y'all in this room, is if you have a plugin that you really like, this could be a way to turn your plugin into like a box that people could use. But I have never experienced with plugging analog audio through the device. So, well.
And I should probably say there's a project at Queen Mary's University, which is using the BeagleBone Black.
Cool.
And they have built a cape which has audio I/O and sensor I/O. And it's using the PRUs on the BeagleBone Black, so it's super low latency.
Cool.
And you can code it in C++ and stuff like that. So it's a very nice solution for working with the BeagleBone Black.
Awesome.
Yeah, it's a very cool platform. Maybe you can take that offline if there's any more questions in the room.
I didn't quite catch, you mentioned something about the way you were doing the vibrato on those samples.
Yes.
Were you doing that inside JUCE? Were you
So
interpolating?
that was all audio samples.
Right, okay.
So that was zero synthesis. I wasn't doing a vibrato effect in JUCE. If I was going to do that project again, the only reason we were crazy enough to do that was because we were trying to be just as pure as possible, just trying to be as true to the instrument as possible. I actually redid that project, sort of like that project in a pure web browser version, and I was just experimenting with web audio, just kind of learn about it. And I made like a Farfisa organ emulation that's MIDI playable there, and that ended up sounding pretty good. So I definitely think you could use JUCE to just create a synthesizer that sounds like an organ that would probably be a lot easier to deal with. Yeah.
Okay. Oh yeah.
I saw on the video of the box you've got a knob.
Yes.
How can you talk about connecting, buttons and knobs, and how you can connect them into your JUCE app?
Yes. So when it comes to the buttons and the knobs, my knob was the simplest knob it could be, which is just a volume knob that was purely analog after all of the conversion. So it didn't actually do any talking to the JUCE app. So it's basically like if you like in a guitar, those little volume knobs. I mean, it's just like a 25 cent $1.50 piece you buy from like Radio Shack, which apparently Radio Shack's not existent anymore. But at the time, I bought it from there. But if you do need to use like physical buttons and physical knobs to talk to your JUCE app, I tried a lot to use the GPIOs, which are basically the usual way that a lot of people talk to their embedded Linux devices, and that stands for General Purpose Input Output. Those, I didn't really like doing that as much. I think the best option would be is to build a smaller MIDI controller to connect into your device. Like maybe build a MIDI controller with an Arduino unit and then connect that into your device. And it sounds like that would be too much effort, but that integrates really well with a system like that has Linux running on it, because then JUCE can just read that MIDI device and just create event calls based on that MIDI device. So I think that actually might be your best option.
Thanks a lot. I'm going to have to cut you off there.
Cool. Thank you, guys.
Cheers.